At this point, we have to decide whether we'll use the C++ standard library or we're going to implement our own. Since I'm developing this game partly to learn about the game engine development, I think it's a great opportunity to implement as many systems myself as possible. So I'm going to start with two of the most basic data structures, arrays and dynamic arrays, commonly known as vector in the C++ STL. An array is a contiguous space in memory that stores multiple elements of the same data type. A dynamic array is the same as an array, but its size can change at runtime. One could ask, why do we need an array data structure since arrays are already built into C++, right? Well, not really. Let's take a look at this code. Here we have an array of 5 integers. At index 0 we have the element 1, and at index 4 we have the element 5. What would happen if we do this? Nothing, that's completely valid code. This is x86 CC4 assembly generated by compiling with GCC 15.2. However, executing this program is undefined behavior, and we want to avoid it as much as possible. This is valid because in C, arrays are just pointers to the first element of the array, so this design decision was inherited by C++. That's one of the reasons to wrap it and create our own array container, or use the C++ STL. So how do we implement an array container? Well, we could have something like this, but that's not very useful for two reasons. First, we are hardcoding the type and element size of the array. Because of that, we could only use this container when we need an array of 5 integers. And second, what's the point of the container if we still have to manually access the inner m elements to operate with the data? We expect to loop an array like this. If we try to compile that, we would get this output. It's complaining about something called begin and end. What's this? Well, let's pause for a second. A structure is just a space in memory that groups data with different data types. In our code, we are telling the compiler that we want to loop our array structure, but the compiler doesn't know how to loop a structure. What's the solution then? We have to explain to the compiler what we mean when we say loop this structure. Now the question is, how do we do that? Searching on the internet, we'll find this thing called iterators, an iterator library. The definition is iterators are a generalization of pointers that allow a C++ program to work with different data structures, for example containers and ranges, in a uniform manner. This definition is an approximation of what we want, but is not fully related to our case. Let's take a look at the definition of stdarray in the standard template library. We see this section called iterators that defines the methods begin and end, the same methods that our compiler was complaining about. Begin returns an iterator to the beginning and end returns an iterator to the end. So it's clear now that we have to implement these methods for our array container. But first we have to implement an iterator. Searching for a better definition of iterator, we find this. This definition says something about using iterators explicitly with operators such as increment and decrement. So whatever our iterator is, we'll need to implement this operator. To sum up, we already know that an iterator is an abstraction over a pointer, and it's used to iterate over a C++ container. So let's wire this up. I call my iterator random access. That's not important for now. Inside our iterator we have the pointer, we are abstracting, and two declarations for overloading the dereference and increment operators. Now we can dereference and increment our random access iterator, just like if it was a raw pointer. Let's implement the begin and end methods to our array container. Following the definition of these methods, begin returns our iterator to the beginning and end returns our iterator to the end. Now our program will look like this. However, we still have one compiler error. Easy enough. We just need to overload the not equal operator in our iterator. Let's do it. So our program will look like this. If we compile and execute it, we'll get this output. Very cool. We are iterating our custom array container. This is a simple example. You surely will need to implement more operators and methods, but you can implement them when you need them. Now let's take a look at the dynamic array. We have to keep track of the number of elements and the capacity of the array. The number of elements is how many elements we have. and the capacity is how many elements fit in the array. Since the size is dynamic, we have to manage memory manually. For that, we'll use our custom allocator from the previous chapter. Also, we have to add the begin and end methods too. We can also add a constructor to make things easier. One of the first methods we should implement for a dynamic array is pushback. This method inserts an element to the back of the array. Basically, this function checks if the array has enough capacity. If not, it reserves more. Then it inserts the element at the back of the array. Let's look at the reserve capacity method. This method checks if the array already has the capacity that we want to reserve. If not, it allocates new memory using our custom allocator and copies the array data to the new buffer. And that's pretty much everything we need. You could start to implement more methods whenever you need them. Another important thing I will leave as an exercise for you is to remove the hard-coded type of the array and dynamic array, and the hard-coded element size from array. See you in the next one.